For millions of years, Earth was home to some of the most frightening animals that have ever existed. Long before humans appeared, giant dinosaurs ruled forests, deserts, rivers, and open plains with powerful jaws, sharp teeth, huge claws, and incredible strength. Some were fast hunters that chased their prey, while others waited for the perfect moment to attack. A few grew taller than houses, and many had senses that helped them survive in a dangerous world. Scientists continue to uncover new fossils that reveal surprising facts about these ancient predators and how they lived. Tyrannosaurus rex was one of the largest and most well-known meat-eating dinosaurs to ever live. It existed during the final part of the Cretaceous period, around 68 to 66 million years ago, in what is now western North America. During this time, the land, climate, plants, and animals were very different from those found on Earth today. Large forests, rivers, floodplains, and coastal areas covered parts of the region where T-Rex lived. Many different types of dinosaurs shared the same environment, but Tyrannosaurus rex became one of the most important predators in its ecosystem. The name Tyrannosaurus rex means tyrant lizard king. Scientists gave it this name because of its large size, powerful body, and role as a major predator. The species was first discovered and described in the early 20th century after fossil remains were found in North America. Since then, many fossils of T-Rex have been discovered, giving scientists important information about its body structure, behavior, growth, movement, diet, and way of life. Tyrannosaurus rex had a very large body. Adult individuals could reach lengths of about 12 meters from the tip of the snout to the end of the tail. Its height at the hips could reach around 4 meters, and when standing upright, its head could be several meters above the ground. The animal had a long, heavy tail that helped balance its body and allowed it to move more effectively. Its body was supported by strong bones and powerful muscles that helped it walk, turn, and interact with its surroundings. The weight of an adult Tyrannosaurus rex has been estimated by scientists using fossil evidence and computer models. Many large individuals may have weighed more than 8 tons. The exact weight varied between different animals because some individuals were younger, smaller, or had different body conditions. A fully grown T-Rex required a large amount of energy to maintain its body, meaning it needed access to enough food to survive. One of the most noticeable features of Tyrannosaurus rex was its enormous skull. The skull was built to handle strong forces during feeding. It was large, thick, and reinforced with strong bones. Unlike many other animals that have lightweight skulls, T-Rex had a heavily built head that could withstand pressure when biting into prey. The skull contained openings that reduced some weight while still maintaining strength. Inside the skull were large teeth that were specially shaped for eating meat. The teeth were thick, strong, and curved. Some of the largest teeth could grow to more than 15 centimeters in length when measured from the root to the tip. These teeth were not thin or delicate. They were designed to handle heavy stress during feeding. When Tyrannosaurus rex closed its jaws, its teeth could penetrate the bodies of other animals and break through tough tissues. The bite of Tyrannosaurus rex was extremely powerful. Scientists have studied its jaw muscles, skull structure, and tooth marks found on fossil bones to understand how it fed. Research suggests that T-Rex had one of the strongest bites among known land animals. Its jaws could create enough force to crush bones while feeding. Fossil evidence shows that some bones from other dinosaurs had deep marks and damage caused by Tyrannosaurus rex teeth. The ability to crush bones gave T-Rex access to nutrients that were not available from soft tissues alone. When feeding, it could consume large amounts of meat, including muscle, organs, and sometimes bones. This feeding style allowed it to gain energy from the remains of large animals. Fossil evidence from dinosaur bones with healing bite marks also suggests that some prey animals survived attacks from Tyrannosaurus rex, showing that interactions between T-Rex and other dinosaurs were complex. The body structure of Tyrannosaurus rex was designed for a powerful predatory lifestyle. Its hind legs were very large and muscular. These legs supported its heavy body and allowed it to move across different environments. The feet contained strong bones and toes that helped support its weight. Although T-Rex was large, it was not simply a slow-moving animal. Its leg structure shows that it was capable of moving efficiently when necessary. Scientists continue to study how fast Tyrannosaurus rex could move. Estimates vary because speed depends on many factors, including muscle strength, body weight, and movement style. Running too quickly could have placed dangerous stress on its bones, so researchers believe it likely moved carefully and used controlled movements. Its ability to walk efficiently would have been important for traveling through its territory and searching for food. Tyrannosaurus rex also had very small arms compared with the rest of its body. These arms were short but strong, with 2 clawed fingers on each hand. Scientists have studied the possible uses of these arms, but their exact purpose remains uncertain. They may have helped with holding objects, supporting the body during certain movements, or other activities. Despite their small size, the arms had strong muscles and were not completely useless. The tail of Tyrannosaurus rex played an important role in movement. It was long, heavy, and made of many vertebrae connected together. The tail helped balance the large head and body while the animal walked. It also helped with turning movements. Without a strong tail, maintaining balance would have been difficult because of the size and weight of the front part of the body. The senses of Tyrannosaurus rex were highly developed. Its eyes faced forward, allowing it to have strong depth perception. This helped it judge distances and track moving objects. Good vision would have been useful when searching for prey across open areas and forests. Scientists have examined the structure of its skull and eye placement to understand how it used its eyesight. Tyrannosaurus rex also had an excellent sense of smell. The part of its brain responsible for processing smells was highly developed. A strong sense of smell would have helped it locate animals over large distances and find dead animals that could provide food. This ability may have been important because finding food was a major challenge for such a large predator. Its brain was relatively large for a dinosaur of its size. Scientists have studied the shape of its brain cavity from fossil skulls to learn about its intelligence and sensory abilities. T-Rex had areas of the brain associated with vision, smell, and coordination that were well developed. This suggests that it was capable of processing information from its environment effectively. Tyrannosaurus rex lived during the final millions of years of the Cretaceous period. At that time, continents were arranged differently from today, and North America contained a large interior seaway that divided parts of the continent during earlier periods. By the time T-Rex lived, many regions had changed, and western North America contained a variety of habitats. Rivers carried water through wide plains, and forests provided environments where many animals lived. The environment of T-Rex included many other dinosaurs and animals. Large plant-eating dinosaurs lived in the same areas, including horned dinosaurs such as Triceratops and duck-billed dinosaurs such as Edmontosaurus. These animals likely formed an important part of the food supply for large predators. Other smaller predators and scavengers also lived in the same ecosystems and interacted with the remains of dead animals. Tyrannosaurus rex was not present across the entire world. Fossil discoveries show that it lived mainly in western North America, including areas that are now parts of the United States and Canada. Fossils have been found in several regions, including Montana, Wyoming, South Dakota, and Alberta. These discoveries have helped scientists understand where the species lived and how it changed over time. The discovery of Tyrannosaurus rex fossils has provided some of the most detailed information available about large, predatory dinosaurs. Many specimens have been found with different levels of preservation. Some fossils include parts of the skull, teeth, bones, and other remains. A few discoveries have been especially important because they preserve large portions of the skeleton, allowing scientists to study the animal's body in detail. Spinosaurus was a large predatory dinosaur that lived during the Cretaceous period, a time in Earth's history when many different types of dinosaurs existed. It lived approximately 100 million to 94 million years ago in what is now North Africa. Fossils of this unusual dinosaur have provided scientists with important information about how some dinosaurs adapted to different environments and how certain predators developed special features for hunting and surviving. Spinosaurus belonged to a group of dinosaurs called Spinosaurids. These dinosaurs were known for their long skulls, narrow snouts, and adaptations connected to eating fish and living around water. Spinosaurus was among the largest members of this group and one of the largest meat-eating dinosaurs known from fossil discoveries. Its body had several unusual features that made it different from many other large predatory dinosaurs. The discovery of Spinosaurus began in the early 20th century when fossils were found in North Africa. The first known remains were discovered in Egypt by a German paleontological expedition led by Ernst Stromer in 1912. The fossils included parts of the skull, vertebrae, and the long spines that gave the dinosaur its name. The name Spinosaurus means spine lizard, referring to the tall spines that extended from the bones of its back. The original fossils were later destroyed during the Second World War when the museum where they were stored was damaged. Because many of the early remains were lost, scientists had to study later discoveries from other locations in North Africa to better understand this dinosaur. New fossils found in places such as Morocco helped researchers learn more about the animal's body shape, lifestyle, and behavior. Spinosaurus was a very large dinosaur. Scientists estimate that it may have reached lengths of more than 14 meters, although the exact size remains uncertain because complete skeletons have not been discovered. The available fossils show that it had a long body, a long tail, a large head, and strong limbs. Its size made it one of the largest known predatory dinosaurs. The skull of Spinosaurus was one of its most important features. Unlike the shorter and wider skulls of many other large meat-eating dinosaurs, Spinosaurus had a long and narrow skull. Its snout extended forward and had a shape similar to that of modern crocodilians. This shape helped it capture prey in water. The jaws of Spinosaurus contained many cone-shaped teeth. These teeth were not shaped like the sharp, blade-like teeth found in some other predatory dinosaurs. Instead, they were long, round, and strong. Their shape was useful for gripping slippery prey, such as fish. The teeth were arranged along the edges of the jaws and helped Spinosaurus hold onto animals that moved quickly in water. The structure of the skull suggests that Spinosaurus was well adapted for catching aquatic animals. The long snout allowed it to reach into water and seize prey. Openings in the skull reduced its weight and may have helped strengthen the structure of the jaws. Scientists believe that the animal used its mouth to capture fish and other creatures that lived in rivers and coastal areas. The environment where Spinosaurus lived was very different from the modern landscapes of North Africa. During the Cretaceous period, parts of this region contained large river systems, wetlands, and coastal areas. These environments provided many sources of food. During the Cretaceous period, parts of this region contained large river systems, wetlands, and coastal areas. These environments provided many sources of food, including fish, aquatic reptiles, and other animals. Spinosaurus lived in areas where water played an important role in daily survival. One of the most noticeable features of Spinosaurus was the tall structure on its back. This structure was formed by extremely long spines that grew from the bones of the spine. These spines were much longer than those found in many other dinosaurs. The exact purpose of this structure is still debated among scientists. The spines supported a large area of skin and tissue, creating a raised structure along the animal's back. Some scientists have suggested that this structure may have been used for display, helping individuals recognize each other or communicate with members of the same species. Others have suggested that it may have played a role in regulating body temperature. The exact function remains uncertain because soft tissues are rarely preserved in fossils. The back spines were not simply decorative bones, they were strong structures connected to the vertebrae. Their size shows that they were an important part of the dinosaur's body. The presence of these long spines helped scientists identify Spinosaurus fossils and distinguish them from other dinosaurs. Spinosaurus also had unusual limb features. Its arms were large and powerful, with strong bones and large claws. The claws were curved and sharp, allowing the animal to grab prey. These arms were different from the small arms of some other large predatory dinosaurs. The strength of the arms suggests that they were useful during hunting and handling captured animals. The hands of Spinosaurus had 3 fingers, each ending in a claw. The largest claw was especially noticeable because of its size and strength. Scientists believe these claws may have helped the dinosaur catch fish, hold struggling prey, or interact with its environment near water. Another important feature of Spinosaurus was its dense bones. Many land animals have hollow bones that reduce body weight and make movement easier. Spinosaurus had bones with greater density, a feature that may have helped it remain stable in water. Dense bones are also found in many modern aquatic animals because they help control movement in underwater environments. The body structure of Spinosaurus suggests that it spent a significant amount of time near water. Scientists have found evidence that it had several adaptations connected to swimming and aquatic hunting. These included its long snout, cone-shaped teeth, dense bones, and strong arms. The tail of Spinosaurus was also unusual. Fossil discoveries have shown that its tail was long and flexible, with a shape that could have helped it move through water. The tail contained tall neural spines and expanded bones that increased its surface area. Researchers believe this tail may have helped the dinosaur push itself through water while hunting. Spinosaurus likely hunted in rivers, lakes, and coastal environments. Its diet probably included large fish and other aquatic animals. Fossils from its stomach area are not commonly preserved, but the shape of its skull and teeth provides evidence about the types of prey it could capture. The dinosaur may have moved between land and water. It had strong legs that allowed it to walk on land, but many of its features suggest that water was an important part of its lifestyle. It may have searched for food in shallow waters and along riverbanks where fish and other animals were available. The discovery of Spinosaurus changed scientists' understanding of large predatory dinosaurs. For many years, researchers believed that the largest meat-eating dinosaurs were mainly land hunters. Studies of Spinosaurus showed that some large predators developed special features for living and hunting in aquatic environments. Spinosaurus remains one of the most studied dinosaurs because of its unusual anatomy. Every new fossil discovery provides more information about its appearance, movement, and behavior. Scientists continue to examine its bones and compare them with other animals to understand how it lived millions of years ago. The history of Spinosaurus research has included many changes as new evidence appeared. Early interpretations were based on limited fossils, so scientists originally had only a small amount of information. Later discoveries revealed that the dinosaur had a more complex body structure than previously believed. The fossils of Spinosaurus have been found mainly in North Africa, especially in regions that were once covered by rivers and coastal waters. These areas preserved evidence of many ancient animals that lived during the Cretaceous period. The fossils provide a record of an ecosystem where Spinosaurus existed alongside many other creatures. The animals that lived alongside Spinosaurus included different types of fish, crocodile relatives, turtles, and other dinosaurs. This environment provided many opportunities for a large predator that could capture aquatic prey. The availability of large fish likely played an important role in the development of Spinosaurus's hunting adaptations. The long snout of Spinosaurus allowed it to search through water for prey. Its teeth were positioned for holding animals rather than cutting them apart. After capturing prey, it likely swallowed smaller animals whole or tore apart larger ones using its jaws and claws. The exact behavior of Spinosaurus remains uncertain because scientists cannot directly observe an animal that lived millions of years ago. Researchers use evidence from fossils, bone structure, and comparisons with living animals to develop explanations about its lifestyle. New discoveries can change these interpretations as more information becomes available. The size and structure of Spinosaurus show that it was a highly specialized predator. Its body contained features that helped it survive in the environments of ancient North Africa. Its long skull, strong claws, dense bones, and tall back spines made it a unique dinosaur among known species. Spinosaurus had a body designed for a lifestyle that involved both land and water. The shape of its bones, skull, and limbs shows that it was not only a large predator, but also an animal that developed features connected to hunting in aquatic environments. The rivers and coastal regions where it lived contained many types of prey, and Spinosaurus had physical characteristics that allowed it to take advantage of these resources. The way Spinosaurus moved has been a subject of scientific research. Because complete skeletons are not available, scientists continue to study how it walked and how much time it spent in water. Its powerful legs allowed it to move across land, while its dense bones and long tail suggest that it could also move through water. The animal probably used different methods of movement depending on whether it was on land or in an aquatic environment. The tail of Spinosaurus attracted much attention after new fossils revealed its unusual shape. Unlike the tails of many large predatory dinosaurs, which were mainly used for balance while walking, the tail of Spinosaurus appears to have had features that could have helped with swimming. It was long, flexible, and supported by tall bones that increased its size. This structure may have allowed the dinosaur to push water backward and move forward while hunting. Scientists have studied the tail by creating models and examining how it may have moved in water. These studies suggest that the tail could produce movement similar to the tails of some modern aquatic animals. This does not mean that Spinosaurus lived entirely in water, but it provides evidence that swimming may have been an important part of its behavior. The legs of Spinosaurus were also unusual. Earlier ideas about the dinosaur's appearance were based on incomplete fossils, and scientists once imagined it as a more traditional land-based predator. Later discoveries showed that its body proportions were different from many other large meat-eating dinosaurs. Its hind limbs were relatively shorter compared with its long body and skull, which may have affected how it moved. The feet of Spinosaurus were strong and supported its large body. Although its exact walking style is still debated, it was capable of moving on land. It likely walked through muddy areas, riverbanks, and coastal environments where it searched for food. The lifestyle of Spinosaurus required it to find and capture prey in places where water and land met. Ancient rivers provided large fish and other aquatic animals. These food sources were important because Spinosaurus had a skull and teeth that were especially suited for catching animals in water. The diet of Spinosaurus was mainly made up of fish, according to many scientific studies. Fossil evidence has shown that it consumed aquatic animals. Some discoveries have included remains of fish associated with spinosaurid fossils, supporting the idea that fish formed an important part of its diet. However, Spinosaurus was not limited to fish alone. As a large predator, it may also have hunted other animals when opportunities appeared. It could have captured smaller dinosaurs, reptiles, and other creatures living near rivers. Its strong arms and claws would have helped it handle different types of prey. The hunting method of Spinosaurus was different from that of many other large predatory dinosaurs. Its long jaws and cone-shaped teeth were useful for quickly grabbing prey. It may have waited near water and used its long snout to catch fish passing nearby. It could also have searched through shallow water for animals hiding beneath the surface. The eyes and nostrils of Spinosaurus were positioned in a way that may have helped it hunt in water. Its nostrils were located farther back on the skull compared with many land animals. This placement may have allowed the dinosaur to keep much of its head in the water while still breathing. The skull of Spinosaurus contained openings that may have reduced weight and supported the structure of its long jaws. The design of the skull helped it handle the forces created when catching prey. The narrow shape allowed it to move its head through water with less resistance. The teeth of Spinosaurus were replaced throughout its life, as happened in many dinosaurs. When a tooth became damaged or worn down, a new tooth grew to replace it. This process allowed the animal to continue feeding effectively throughout its lifetime. The claws of Spinosaurus were another important part of its hunting ability. The large claws on its hands were strong and curved. They could have been used to hold fish, capture smaller animals, and defend itself from threats. The strength of its arms made them useful tools for interacting with its environment. Spinosaurus lived during a time when many different dinosaur groups existed. The Cretaceous period contained a wide variety of animals, including large herbivorous dinosaurs, smaller predators, flying reptiles, and marine creatures. North Africa had complex ecosystems where many species competed for food and survival. The climate of ancient North Africa was different from today. Many areas that are now dry deserts once contained rivers, forests, and wetlands. These environments supported a wide range of life. Spinosaurus lived in these wetter landscapes, where water sources were common and provided habitats for fish and other animals. The fossils of Spinosaurus have helped scientists understand how dinosaurs adapted to different environments. Not all dinosaurs lived in the same way. Some were specialized for running on land, some for flying, and some, like Spinosaurus, developed features connected to aquatic environments. The scientific study of Spinosaurus continues because many questions remain unanswered. Researchers still investigate how it moved, how it hunted, and how it used its large back spines. Fossil discoveries and new research methods continue to provide more details about this dinosaur. Modern technology has helped scientists study Spinosaurus fossils in greater detail. Three-dimensional scans, computer models, and other scientific techniques allow researchers to examine bones without damaging them. These methods help reveal information about the dinosaur's body structure and possible behavior. The reconstruction of Spinosaurus has changed several times as new evidence appeared. Early drawings showed it as a more traditional large predator, standing on strong legs. Later studies suggested a body better suited for life near water. These changes demonstrate how scientific understanding develops when new evidence becomes available. The discovery of new Spinosaurus fossils in Morocco provided important information about the dinosaur's anatomy. These fossils included parts of the tail and other bones that were previously unknown. They helped scientists create a clearer picture of how the animal may have looked and moved. The tall spines on the back of Spinosaurus remain one of its most recognizable features. These spines extended upward from the vertebrae and created a large structure along the back. The purpose of this feature continues to be studied. It may have helped with communication between individuals, temperature control, or other functions. If the back structure was used for communication, it may have helped individuals recognize members of their own species. Large body structures are found in many modern animals and can serve different purposes related to social behavior. However, scientists cannot determine the exact role of the Spinosaurus sail-like structure with complete certainty. If the structure helped control body temperature, it may have played a role in absorbing or releasing heat. Animals use different body features to manage temperature, especially in environments where conditions change. More evidence is needed to understand whether this was an important function for Spinosaurus. The name Spinosaurus became widely known because of its unusual appearance and size. It has become one of the most studied dinosaurs in paleontology. Its fossils have helped researchers examine how some dinosaurs adapted to life around water. Spinosaurus also shows how dinosaur evolution produced many different body forms. Dinosaurs were not all built the same way or used the same methods to survive. Different environments encouraged different physical adaptations, and Spinosaurus developed features connected to the rivers and coastal regions where it lived. The fossil record of Spinosaurus provides information about an animal that lived millions of years before humans existed. Its bones preserve details about its growth, movement, and feeding habits. Scientists carefully examine these remains to understand the biology of this ancient predator. The growth of Spinosaurus from a young animal to an adult would have involved major changes in body size and structure. Young individuals likely had different proportions from adults. As they grew, their skulls became longer, their bodies became larger, and their hunting abilities increased. Like other dinosaurs, Spinosaurus began life as a young animal that depended on its parents or its own ability to survive. Fossil evidence about Spinosaurus eggs and nests has not been discovered clearly, so scientists know less about its reproduction compared with some other dinosaurs. The exact lifespan of Spinosaurus is unknown. Scientists estimate the ages of dinosaurs by studying growth patterns in bones. These studies can show how quickly an animal grew and when it reached adulthood, but they cannot provide a precise number of years that an individual lived. Spinosaurus lived for millions of years before disappearing from the fossil record. The reasons for its extinction are connected to the broader changes that affected many species during the end of the Cretaceous period. Environmental changes, changes in ecosystems and other factors influenced the survival of many animals during this period. Giganotosaurus was a large meat-eating dinosaur that lived during the late Cretaceous period, around 99 million to 97 million years ago. Its fossils were discovered in South America, in what is now Argentina. The discovery of Giganotosaurus provided scientists with important information about the types of large predators that existed in the southern continents during the age of dinosaurs. It belonged to a group of dinosaurs called carcharodontosaurs, which included some of the largest known meat-eating dinosaurs that ever lived. The name Giganotosaurus means giant southern lizard. The name refers to its enormous size and the region where its fossils were found. Although the name contains the word lizard, Giganotosaurus was not a modern lizard. It was a theropod dinosaur, a group of mostly meat-eating dinosaurs that walked on two legs. Theropods had strong hind limbs, sharp claws, and powerful jaws that helped them catch and eat other animals. Giganotosaurus was one of the largest members of this group. The first remains of Giganotosaurus were discovered in 1993 by an amateur fossil hunter named Ruben Carolini in Patagonia, a region in southern Argentina. The discovery happened in an area known for its rich dinosaur fossils. When scientists examined the bones, they realized that they belonged to a previously unknown dinosaur species. The fossil material included much of the skull, parts of the spine, hip bones, and leg bones. These remains allowed researchers to study the animal's size, body structure, and possible behavior. Giganotosaurus had a very large body. Scientists estimate that it reached a length of around 13 meters from the tip of its snout to the end of its tail. Some estimates suggest that the largest individuals may have been slightly longer. Its weight has been estimated at several tons, with many scientists placing it somewhere between 6 and 8 tons, although exact measurements remain uncertain because complete skeletons have not been found. The body of Giganotosaurus was built for movement and hunting. It had a long tail that helped it maintain balance while walking and running. The tail contained many vertebrae connected by strong muscles and ligaments. This structure allowed the dinosaur to control its body position while moving. Its large legs supported its heavy body and helped it travel across the landscape in search of prey. The skull of Giganotosaurus was one of its most important features. It was long and narrow, measuring more than 1.5 meters in length. The skull contained many sharp teeth that were shaped for slicing flesh. The teeth were flattened from side to side and had sharp edges that could cut into the bodies of large animals. These teeth were continuously replaced throughout the dinosaur's life. As damaged or broken teeth fell out, and new ones grew in their place. The jaws of Giganotosaurus were powerful and suited for attacking large prey. Instead of using its teeth mainly for crushing bones, it likely used them to create deep wounds in animals. The shape of its teeth allowed it to remove pieces of flesh from large bodies. Its jaw muscles helped it hold onto struggling prey, while its teeth caused serious injuries. The arms of Giganotosaurus were relatively short compared with its large body, but they were still strong. Each arm ended in 3 clawed fingers. These claws may have helped it hold onto prey or interact with objects around it. However, most of its hunting ability came from its head, teeth, jaws, and powerful legs. The environment where Giganotosaurus lived was very different from the modern landscapes of South America. During the late Cretaceous period, the region contained forests, rivers, floodplains, and areas with warm climates. Many types of plants grew there, supporting large populations of plant-eating dinosaurs. These herbivorous dinosaurs became potential sources of food for large predators like Giganotosaurus. One of the animals that may have been hunted by Giganotosaurus was Argentinosaurus, a giant long-necked sauropod dinosaur that lived in the same region. Sauropods had extremely large bodies, long necks, and long tails. Young or injured individuals may have been possible targets for large predators. Scientists continue to study whether Giganotosaurus hunted these giant animals alone, in groups, or mainly attacked smaller dinosaurs. The hunting behavior of Giganotosaurus is still being investigated because there is no direct evidence showing exactly how it captured its prey. Scientists study its body structure, teeth, claws, and the fossils of other dinosaurs from the same period to understand its possible lifestyle. Its long legs suggest that it could move at a reasonable speed, although its large size meant that it probably could not run at extremely high speeds for long distances. Giganotosaurus had adaptations that helped it survive as a predator. Its large body allowed it to attack and consume large animals. Its sharp teeth helped it cut through meat. Its strong legs allowed it to move across wide areas while searching for food. Its powerful senses, including eyesight and smell, likely helped it detect potential prey and other animals in its environment. The brain of Giganotosaurus was relatively small compared with its enormous body, but it still had the abilities needed for survival. It could process information from its surroundings, coordinate movement, and respond to changes in its environment. Like other theropods, it likely depended on its senses to locate prey and avoid dangers. Scientists believe that Giganotosaurus was active during the daytime. Although the exact daily habits of the dinosaur are unknown, it probably spent much of its time moving through its territory, searching for food, resting, and avoiding conflicts with other predators. Large predators often required large amounts of food to maintain their bodies, so finding enough prey would have been an important part of its life. The discovery of Giganotosaurus changed scientific understanding of large predatory dinosaurs in the southern hemisphere. Before its discovery, many of the best-known giant meat-eating dinosaurs had been found in northern regions such as North America. Giganotosaurus showed that extremely large predators also lived in South America during the Cretaceous period. The fossil record shows that South America had many unique dinosaur species during this time. Because the continent was separated from many other land areas, different groups of animals developed independently. Giganotosaurus was part of this unique ecosystem. It lived alongside other dinosaurs that were adapted to the conditions of the ancient South American environment. The relationship between Giganotosaurus and other animals in its ecosystem involved complex interactions. Large herbivorous dinosaurs depended on plants for food, while predators depended on those herbivores as sources of energy. Smaller animals also lived in the same environment, creating a wide network of life forms. Giganotosaurus occupied the role of a major predator within this system. The growth of Giganotosaurus from a young dinosaur to a full-sized adult would have taken many years. Young individuals likely had smaller bodies, lighter weight, and different hunting abilities. As they grew, their skulls became larger, their muscles developed, and their ability to capture larger prey increased. Scientists study fossil bones from different growth stages to learn how these dinosaurs changed during their lives. The bones of Giganotosaurus provide information about its movement and physical abilities. The structure of its legs shows that it was adapted for walking and possibly short bursts of faster movement. Its body was heavy, so conserving energy would have been important. It likely relied on careful movement and powerful attacks rather than constant chasing over long distances. The climate during the time of Giganotosaurus was generally warmer than today. There were no polar ice caps like those found in modern times, and sea levels were often higher. The landscape of Patagonia contained different habitats, including forests and open areas. These environments supported many species of plants and animals that formed the food sources needed by large dinosaurs. Giganotosaurus lived millions of years before the famous extinction event that ended the age of non-avian dinosaurs. It disappeared long before the final extinction of dinosaurs at the end of the Cretaceous period, which occurred around 66 million years ago. The exact reason why Giganotosaurus became extinct is not fully known. Changes in climate, changes in ecosystems, and natural evolutionary changes may have influenced the disappearance of many dinosaur species during the late Cretaceous period. The study of Giganotosaurus continues through new fossil discoveries and scientific research. Paleontologists examine its bones using modern techniques to learn more about its anatomy, growth, and behavior. Computer models, three-dimensional scans, and detailed studies of dinosaur relationships help researchers understand how this animal lived. The teeth of Giganotosaurus remain one of the most studied parts of its body. Their shape shows that the dinosaur was adapted for cutting meat. Scientists can examine wear patterns on fossil teeth to understand how the dinosaur used them. These marks can provide information about the types of food it ate and how it interacted with prey. The skull structure of Giganotosaurus also gives clues about its feeding methods. Its long jaws contained many cutting teeth arranged along the edges. The skull was strong enough to handle the forces created when biting into large animals. However, its feeding style was different from predators that relied mainly on crushing bones. It was more suited to removing large pieces of flesh. The size of Giganotosaurus made it one of the largest known predators from the dinosaur era. Its remains continue to attract interest because they show the variety of large carnivorous dinosaurs that existed around the world. Fossils like those of Giganotosaurus allow scientists to study ancient ecosystems and understand how different animals lived together millions of years ago. The discovery of Giganotosaurus also helped increase interest in the dinosaur fossils of South America. Patagonia has become one of the most important regions for dinosaur research, because many unusual and scientifically valuable fossils have been found there. Continued exploration of this area may reveal more information about Giganotosaurus and other prehistoric animals that lived in the same environment. Giganotosaurus had a combination of physical features that supported its life as a large predator. Its long skull, sharp teeth, strong legs, and large body allowed it to hunt and consume other animals. Its existence shows the wide variety of dinosaur forms that developed during the Cretaceous period and the different ways predators adapted to their environments. Carcharodontosaurus was one of the largest meat-eating dinosaurs that lived during the Cretaceous period. It existed about 100 million to 94 million years ago in what is now North Africa. Fossil remains of this dinosaur have been discovered in areas that were once covered by ancient rivers, forests, and wide floodplains. During this time, the northern part of Africa had a very different environment from the one seen today. It contained many types of plants, animals, and large dinosaur species that lived together in complex ecosystems. The name Carcharodontosaurus comes from Greek words that mean shark-toothed lizard. Scientists gave it this name because its teeth had a shape that was similar to the teeth of large sharks. The teeth were long, flat, and designed for cutting through the flesh of animals. They were not shaped mainly for crushing bones. Instead, they worked like blades that could create deep wounds in prey. The structure of its teeth shows that Carcharodontosaurus was a powerful predator that depended on its jaws and teeth to capture and kill animals. Carcharodontosaurus belonged to a group of dinosaurs called Carcharodontosaurids. These dinosaurs were large theropods, meaning they walked on two legs and had bodies adapted for hunting. The group included several large predators that lived in different parts of the world during the Cretaceous period. Carcharodontosaurus itself became one of the best-known members of this group because of its size, skull structure, and powerful feeding abilities. The body of Carcharodontosaurus was very large. Scientists estimate that it could grow to around 13 meters in length, although the exact size is still studied because fossil discoveries are incomplete. Its body had a long tail that helped it maintain balance while moving. Its back legs were strong and supported its heavy body. Like other theropod dinosaurs, it had 3 toes on each foot, with claws that helped it move through its environment and interact with prey. The skull of Carcharodontosaurus was one of its most important features. It had a very large head that could reach more than 1.5 meters in length. The skull contained many large openings that reduced its weight while still allowing room for strong muscles and important structures. Its jaws were long and powerful, allowing it to deliver strong bites. The shape of the skull shows that it was designed for capturing and cutting large amounts of flesh from other animals. Its teeth were among its most recognizable features. Each tooth was curved, sharp, and had edges that helped slice through meat. The teeth were replaced throughout the dinosaur's life. As damaged or broken teeth could fall out, and new ones would grow in their place. This replacement system was common among many predatory dinosaurs and allowed them to continue feeding even when their teeth became worn from use. Carcharodontosaurus lived in a region that supported many large animals. During its time, North Africa contained rivers, wetlands, and areas with thick vegetation. These environments provided food and shelter for many species. Large plant-eating dinosaurs moved through these areas, creating opportunities for predators to hunt. The presence of several large carnivorous dinosaurs shows that the ecosystems of this period contained many different hunting strategies and feeding patterns. One of the most important discoveries related to Carcharodontosaurus was made in the early 20th century. Fossils were first discovered in North Africa, especially in areas that are now part of Morocco and Algeria. Early discoveries included parts of the skull and teeth which allowed scientists to identify the dinosaur as a new species. Later discoveries provided more information about its body structure and helped researchers understand its size and lifestyle. The fossils of Carcharodontosaurus have helped scientists study how large predators lived during the middle part of the Cretaceous period. The dinosaur lived at a time when many different types of large theropods existed around the world. Fossil evidence from Africa shows that several giant predators shared the same landscapes. These animals likely had different roles within their environments, using different methods to find food and survive. Carcharodontosaurus lived alongside Spinosaurus, another very large predator from North Africa. Both dinosaurs were part of the same ecosystem, but they had different body features. Carcharodontosaurus had a large skull with teeth designed for cutting flesh, while Spinosaurus had a long, narrow snout and features connected to life near water. Their differences suggest that they may have focused on different types of prey and used different hunting methods. The environment where Carcharodontosaurus lived also contained other large dinosaurs. Fossils from North Africa show the presence of many species that shared the same regions. Large plant-eating dinosaurs provided potential food sources for predators. Smaller animals also lived in these environments, creating a wide range of interactions between different species. The hunting behavior of Carcharodontosaurus has been studied through its skull and teeth. Its jaws were built to deliver strong bites that could remove large pieces of flesh from prey. Scientists believe it may have attacked large herbivorous dinosaurs that lived in the same environment. However, the exact details of how it hunted are still being researched. because direct evidence of hunting behavior is difficult to find in the fossil record. Its long skull and sharp teeth suggest that it relied heavily on quick strikes and powerful jaw movements. When attacking prey, it may have used its teeth to create serious injuries, and then continued feeding as the animal became weaker. The structure of its skull indicates that it was adapted for processing large amounts of meat. Carcharodontosaurus also had strong neck muscles that supported its large head. A heavy skull required powerful muscles to control movement during feeding. The connection between the skull and the neck shows that the dinosaur had the strength needed to move its head while biting and tearing food. The discovery of Carcharodontosaurus changed scientists' understanding of large predators that lived in Africa during the Cretaceous period. Before many of these fossils were discovered, knowledge about African dinosaurs was limited. New findings showed that Africa supported some of the largest and most specialized predatory dinosaurs known from the fossil record. The study of Carcharodontosaurus fossils has also provided information about dinosaur evolution. Its features show how different groups of theropods developed specialized body structures over millions of years. Large predators evolved different skull shapes, teeth, and body forms depending on their environments and available food sources. The climate of North Africa during the time of Carcharodontosaurus was warmer and wetter than today. Large areas contained rivers and forests where many animals could live. These conditions allowed many large dinosaurs to survive. The landscape supported complex food systems where plants, herbivores, and predators were connected through feeding relationships. Carcharodontosaurus was not the only predator in its environment. Several large carnivorous dinosaurs existed during the same period. The presence of multiple predators created a situation where different species occupied different parts of the ecosystem. Some may have hunted different animals, while others may have focused on different areas of the environment. The size of Carcharodontosaurus made it one of the largest predators of its time. Its estimated length of around 13 meters and its massive skull show that it was adapted for hunting large prey. Its physical features provide important evidence about the lives of giant theropods and their role in ancient ecosystems. Deinonychus was a highly active and powerful meat-eating dinosaur that lived during the early Cretaceous period, about 115 million to 108 million years ago. Its fossils have been discovered in parts of North America, where it lived in environments that included forests, open areas, rivers, and floodplains. The dinosaur belonged to a group called dromaeosaurids, which were known for their sharp claws, flexible bodies, and hunting abilities. The name Deinonychus means terrible claw, a name given because of the large curved claw found on each of its hind feet. Deinonychus was not a very large dinosaur when measured by body size, but it had several features that made it a dangerous predator. It had a strong and well-built body designed for quick movements and active hunting. Scientists estimate that it reached lengths of around 3 meters from the tip of its snout to the end of its tail. Its body was balanced by a long, stiff tail that helped it maintain stability while running, turning, and making sudden movements. One of the most important features of Deinonychus was the large sickle-shaped claw on the second toe of each hind foot. This claw was long, curved, and sharp. Unlike the other toes, this toe could be lifted upward when the dinosaur walked, keeping the claw away from the ground and preventing it from becoming damaged. During an attack, Deinonychus could raise its foot and bring the claw downward toward its prey. The claw may have been used to grip, hold, or injure animals during hunting. The exact way Deinonychus used its famous foot claws is still studied by scientists. Some researchers believe that the claws helped the dinosaur hold onto prey while using its jaws and hands to attack. Others suggest that the claws may have been used to deliver deep wounds. The shape and structure of the claw show that it was an important part of the dinosaur's hunting equipment. Deinonychus had a lightweight body that allowed it to move quickly. Its bones were built to provide strength while reducing unnecessary weight. This body structure helped it chase animals, change direction rapidly, and remain active for long periods. Its legs were long and muscular, giving it the ability to move across different types of land while searching for food. The arms of Deinonychus were also an important part of its body. It had long arms with 3 fingers on each hand. Each finger ended in a sharp claw that could be used for holding onto prey, pulling food closer, or helping the dinosaur interact with its surroundings. The arms were strong and flexible, allowing the dinosaur to use them during attacks. Its head contained a long skull filled with sharp, curved teeth. These teeth were designed for cutting and tearing flesh. The jaws were strong enough to remove pieces of meat from animals that it captured. The teeth were not used for chewing because dinosaurs like Deinonychus swallowed pieces of food after tearing them apart. Deinonychus had large eyes and well-developed senses that helped it detect movement and locate potential prey. Its ability to see, hear, and respond quickly would have been useful while hunting. A predator that depended on active movement needed to identify animals nearby and react quickly when an opportunity appeared. The environment where Deinonychus lived contained many different animals that could have served as food sources. During the early Cretaceous period, North America had a variety of dinosaurs, reptiles, and other creatures. Deinonychus likely hunted smaller animals and may also have attacked larger dinosaurs when conditions allowed. One of the animals associated with Deinonychus fossils is Tenontosaurus, a plant-eating dinosaur that was much larger than Deinonychus. Some fossil sites contain the remains of several Deinonychus individuals near Tenontosaurus remains, leading scientists to study whether these predators hunted in groups. The idea that Deinonychus hunted together has been widely discussed among scientists. Fossil evidence suggests that multiple individuals may have gathered around a large prey animal. This discovery raised questions about whether Deinonychus had organized group hunting behavior. Some scientists believe that several individuals may have worked together to bring down larger animals. Others believe that the dinosaurs may have gathered around a dead animal, rather than cooperating during a planned attack. The social behavior of Deinonychus remains uncertain because fossils cannot show every detail of how an animal behaved when it was alive. Scientists study bone arrangements, injuries, footprints, and other evidence to understand how dinosaurs may have interacted. The possibility of group behavior in Deinonychus has influenced many studies about dinosaur intelligence, communication, and hunting methods. Deinonychus was a member of the Dromaeosaurid family, a group of dinosaurs that included many small and medium-sized predators. These dinosaurs shared features such as sharp claws, long tails, and active lifestyles. Deinonychus became one of the most studied members of this group because its fossils provided important information about how some dinosaurs moved and hunted. The discovery of Deinonychus changed scientific views about dinosaurs. Before discoveries involving Deinonychus, many people thought dinosaurs were slow animals that moved with little activity. The study of this dinosaur showed evidence of a more active lifestyle, with strong muscles, flexible movement, and specialized hunting features. Research on Deinonychus helped scientists understand that many dinosaurs were energetic animals with complex behaviors. The first major discoveries of Deinonychus fossils were made during the 1960s in Montana, United States. Paleontologist John Ostrom studied the fossils and described the dinosaur scientifically in 1969. His research examined the structure of the dinosaur's body, especially its limbs, claws, and movement abilities. The findings contributed greatly to new ideas about dinosaur biology and their relationship with birds. Deinonychus had several characteristics that connected it with other theropod dinosaurs. Theropods were a group of mostly meat-eating dinosaurs that walked on two legs. They included many famous predators with different body sizes and shapes. Deinonychus showed features that helped scientists understand how certain theropods developed active hunting methods and advanced body structures. The tail of Deinonychus played an important role in movement. It was long and made of many connected bones that created a stiff structure. This tail helped the dinosaur maintain balance while running and making quick turns. When the dinosaur moved rapidly, the tail likely worked together with the legs and body to control direction. The feet of Deinonychus were specially adapted for movement and hunting. The raised sickle claw allowed the dinosaur to walk without constantly damaging its most important weapon. Its other toes helped support its body while moving across different surfaces. The combination of strong legs and specialized feet gave Deinonychus a unique way of interacting with its environment. The diet of Deinonychus mainly consisted of meat. It likely hunted animals that it could capture using its speed, claws, and jaws. It may have searched for prey across large areas, using its senses to locate possible targets. After catching prey, it would have used its teeth and claws to remove pieces of flesh. Scientists continue to investigate how much force Deinonychus could produce with its bite and claws. Studies of its skeleton show that it had strong muscles connected to its legs and arms. These features suggest that it was capable of powerful movements during hunting and feeding. Deinonychus also provides important information about the evolution of birds. Many features found in dromaeosaurids are similar to features found in modern birds, including lightweight bones and certain body structures. Research into dinosaurs like Deinonychus has helped scientists study the changes that occurred during the evolution of birds from theropod dinosaurs. The body of Deinonychus was covered with scales, and some closely related dinosaurs had feathers. Scientists continue to study whether Deinonychus itself had feathers. Evidence from related species suggests that feather-like structures were common among many small theropods, but the exact appearance of Deinonychus remains an area of scientific research. Young Deinonychus individuals likely went through different stages of growth before reaching adult size. Like many dinosaurs, it probably changed in body shape as it matured. Younger individuals may have had different movement abilities and hunting roles compared with adults. Fossil studies of related dinosaurs show that growth patterns can provide information about how these animals developed throughout their lives. Deinonychus lived millions of years before humans appeared. During its time on Earth, it occupied ecosystems where many types of plants and animals existed. It was part of a complex environment where predators and prey interacted through feeding, movement, and survival behaviors. Utahraptor was a large predatory dinosaur that lived during the early Cretaceous period, about 130 million to 125 million years ago. Its fossils were discovered in North America, especially in the area that is now the state of Utah in the United States. The dinosaur belonged to a group of meat-eating dinosaurs known as dromaeosaurids, which are commonly called raptors. Utahraptor became known as one of the largest and most powerful members of this group because of its size, strong body, and large curved claws. When Utahraptor lived, the Earth was very different from today. The continents were arranged differently, and many areas that are now dry land had different climates and environments. The region where Utah raptor lived contained forests, rivers, floodplains, and areas with plants that supported many types of animals. This environment provided places where predators could search for prey and where different dinosaur species could survive. Utah raptor was a large animal with a body length of about 7 meters from its snout to the end of its tail. Its body was built for hunting and movement. It had a long tail that helped it keep balance while walking, running, and making quick turns. The tail was made of many connected bones and could be held in different positions, depending on how the animal was moving. This allowed Utah raptor to control its body movements while chasing prey or moving through its environment. The most famous feature of Utah raptor was the large curved claw on each of its feet. These claws were located on the second toe of each foot and could grow to a very large size. The claws had a sickle-like shape, meaning they were curved and pointed. The dinosaur could lift these claws away from the ground while walking and use them when attacking or holding onto prey. The shape and size of these claws show that they were important short tools for hunting. Utah raptor's feet were strong and supported its large body. The large toe claws were not used for normal walking because keeping them raised helped protect their sharp edges. When Utah raptor attacked, it could place these claws against another animal and use its powerful leg muscles to create strong movements. The legs of this dinosaur contained large muscles that helped it move with force and stability. The body of Utah raptor was strong and heavily built. Many raptor dinosaurs were smaller and lighter, but Utah raptor had a much larger body structure. It had strong bones, powerful legs, and a muscular frame that allowed it to handle large prey animals. Its size gave it the ability to hunt animals that smaller predators could not easily attack. Utah raptor had strong arms with 3 fingers on each hand. Each finger ended in a sharp claw. The arms were useful for holding onto prey and helping the dinosaur control animals during an attack. The hands were not designed for walking but were specialized for catching and gripping. The muscles connected to the arms allowed Utah raptor to use them effectively during hunting. The head of Utah raptor contained sharp teeth that were designed for cutting meat. Its teeth were curved and had edges that helped it tear pieces from animals. The skull was strong enough to support the muscles needed for biting. Although the skull was not as large as some other giant meat-eating dinosaurs, it was well suited for the hunting style of a raptor. The jaws of Utah raptor were filled with many teeth, arranged along the upper and lower parts of its mouth. These teeth were shaped to help the dinosaur hold on to struggling prey and remove pieces of flesh. The teeth were not meant for crushing hard materials, but were adapted for eating other animals. Scientists believe Utah raptor was an active predator that hunted other animals in its environment. It likely used its senses, including sight and smell, to find potential prey. Its eyes faced forward, which may have helped it judge distances and track moving animals. Good vision would have been useful when approaching prey and deciding the right moment to attack. The exact hunting behavior of Utah raptor is still studied by scientists because there is limited fossil evidence showing how it behaved. Some researchers believe it may have hunted alone, while others suggest that some raptor dinosaurs may have had social behaviors. Fossil discoveries of related dinosaurs have provided evidence that some members of the raptor group may have interacted with each other, but direct evidence about Utah raptor's social life remains uncertain. Utah raptor lived alongside many other animals during the early Cretaceous period. Its environment contained different types of dinosaurs, reptiles, and other creatures. It was part of a complex ecosystem where predators and prey depended on each other. Herbivorous dinosaurs living in the same region provided possible food sources for large predators like Utahraptor. The discovery of Utahraptor changed scientific understanding of raptor dinosaurs. Before its discovery, many famous raptor fossils were from smaller species. The size of Utahraptor showed that some members of this group could become much larger than previously known. Its fossils helped scientists study how these dinosaurs developed different body sizes and hunting abilities. The first important fossils of Utahraptor were discovered in Utah in the early 1990s. The discovery involved several fossil remains, including parts of the skull, bones from the limbs, and the large foot claw that became a major identifying feature of the species. Scientists studied these remains and officially named the dinosaur Utahraptor ostromyces. The name Utahraptor refers to the place where the fossils were discovered, while the second part of its scientific name honors people connected with the study and support of dinosaur research. The discovery attracted attention because the fossils represented a very large raptor dinosaur that had not been known before. The size of Utahraptor made it one of the largest known dromaeosaurids. It was not a small, lightweight animal. It had a heavy body, strong muscles, and large weapons for hunting. Its structure shows that it was adapted for a life as a predator. Utahraptor probably moved using 2 legs. Its back legs carried most of its body weight, while its arms were used for catching and controlling prey. The ability to walk and run on 2 legs gave it freedom to use its hands for other activities. Its body shape allowed it to move through different types of terrain while searching for food. The legs of Utahraptor were among its most important features. Strong leg muscles provided power for movement and attacks. The large claws on its feet were connected to these powerful legs, allowing the dinosaur to use its entire body during hunting. The combination of strong legs and sharp claws made its attacks effective. Scientists have studied the bones of Utahraptor to understand how it grew and how it lived. Fossil evidence shows that it had features shared with other dromaeosaurids, including a flexible tail, curved claws, and a lightweight but strong skeleton. These characteristics helped members of this dinosaur group become successful hunters. There is evidence that many dromaeosaurids had feathers. Because Utahraptor belonged to this group, scientists think it may also have had feathers covering parts or most of its body. However, direct fossil evidence of Utahraptor's feathers has not been found. The possibility of feathers is based on evidence from closely related dinosaurs. If Utahraptor had feathers, they would have served different purposes. Feathers may have helped with body temperature control, communication, and protection. They would not have allowed Utahraptor to fly because its body size and structure were not suitable for flight. The feathers would have been part of its normal body covering. Utahraptor's environment included many challenges. Finding food, avoiding injuries, and surviving changes in climate were important parts of its daily life. Like other predators, it needed enough energy to support its large body. Hunting required careful movement and the ability to respond quickly to opportunities. The diet of Utahraptor mainly consisted of meat. It likely hunted animals smaller than itself and possibly attacked larger animals when conditions allowed. Its teeth, claws, and body strength were all useful for catching and eating prey. The exact animals it hunted are still being studied because fossil evidence of direct interactions between Utahraptor and its prey is limited. Utahraptor was discovered during a period when many new dinosaur fossils were being studied in North America. Its discovery provided more information about dinosaur diversity during the early Cretaceous period. It showed that large predators existed millions of years before some of the better-known giant, meat-eating dinosaurs from later periods. The fossil record of Utahraptor remains incomplete. Scientists have not found every part of its skeleton, and many details about its behavior are still being investigated. Each new fossil discovery can provide additional information about its body, growth, movement, and relationship with other animals. Utahraptor had several features that made it a specialized predator. Its large foot claws, strong legs, sharp teeth, and gripping hands were all connected to its hunting lifestyle. Its body was designed to capture and handle prey in the environment where it lived. The dinosaur lived millions of years before humans appeared on Earth. During its time, dinosaurs were the dominant land animals, and many different species occupied different roles in ecosystems. Utahraptor was one of the predators that lived during this period and interacted with the animals around it. Allosaurus was a large meat-eating dinosaur that lived during the late Jurassic period, about 155 million to 145 million years ago. It was one of the most important predators in the environments where it lived, especially in what is now known as North America. During its time, many different types of dinosaurs lived across the land, including plant-eating dinosaurs of various sizes and other meat-eating species. Allosaurus occupied a position as a powerful hunter that depended on its body structure, sharp senses, and physical strength to capture and consume other animals. The name Allosaurus means different lizard, a name given because of features in its bones that appeared different from those of other dinosaurs known at the time of its discovery. It belonged to a group of dinosaurs called theropods, which included many meat-eating dinosaurs. Theropods were known for walking on two legs, having sharp teeth, and using their bodies for active hunting. Allosaurus had many features that helped it survive as a predator, including a large head, strong jaws, sharp teeth, muscular legs, and short but powerful arms. Allosaurus reached lengths of around 9 meters. Its body was long and balanced, with a large tail that helped it maintain stability while moving. Its skeleton was built for walking and running on 2 strong hind legs. The animal had a long body, a relatively lightweight structure compared with some other large predators, and strong muscles attached to its bones. These features allowed it to move across the landscapes of the late Jurassic period while searching for food. The head of Allosaurus was one of its most noticeable features. It had a large skull that contained many sharp teeth arranged along its jaws. These teeth were curved and had rough edges called serrations. The serrated edges helped the dinosaur cut through the flesh of the animals it hunted. The teeth were replaced throughout its life, meaning that damaged or lost teeth could grow again. This ability was common among many meat-eating dinosaurs and allowed them to continue feeding even when their teeth became worn or broken. The skull of Allosaurus was designed to handle the demands of hunting. It was large enough to contain strong jaw muscles and many teeth, but it also had openings and spaces that reduced the overall weight of the head. These openings were part of the natural structure of theropod skulls and helped create a balance between strength and weight. The shape of the skull allowed Allosaurus to open its mouth widely and use its jaws when attacking prey. Allosaurus had powerful jaws, although much of its hunting ability also came from other parts of its body. Its neck muscles were strong and supported the movement of its large head. Scientists studying Allosaurus fossils have examined the structure of its skull, teeth, and neck to understand how it may have captured and eaten other animals. Evidence suggests that it used its head and jaws actively when feeding. The arms of Allosaurus were shorter than its legs, but they were still strong and useful. Each arm had 3 clawed fingers. These fingers ended in sharp claws that could grip and hold onto prey. The arms were positioned close to the front of the body. allowing the dinosaur to use them during hunting and feeding. Although the arms were not as long or as powerful as its legs, they played an important role in its ability to interact with other animals. The 3 fingers on each hand had joints that allowed movement. The claws could be used for holding, pulling, and controlling prey. Fossil evidence from theropod dinosaurs shows that their arms were active parts of their hunting behavior. Allosaurus depended on more than just its teeth when dealing with large animals. Its claws and arms added another way for it to control and feed on prey. The legs of Allosaurus were among its strongest body parts. It walked upright on 2 muscular hind legs, and its feet had strong toes with claws. These legs supported its large body and allowed it to travel across different types of terrain. The muscles attached to its leg bones show that it had a powerful lower body. This strength was important because hunting required movement, balance, and the ability to approach or follow other animals. The tail of Allosaurus was long and strong. It helped balance the body while the dinosaur moved and turned. Because Allosaurus walked on 2 legs, maintaining balance was very important. The tail worked with the rest of the body to keep the animal stable during movement. The structure of the tail shows that it was an important part of the dinosaur's overall body design. Allosaurus lived in areas that contained a variety of environments, including forests, open spaces, and areas near rivers and lakes. These environments supported many kinds of plants and animals. Plant-eating dinosaurs provided possible sources of food for large predators. The late Jurassic period was a time when many dinosaur groups were widespread, and ecosystems contained many different species living together. Fossils of Allosaurus have been discovered mainly in western areas of North America, especially in regions that were once part of ancient floodplains and forests. These discoveries have provided scientists with information about the dinosaur's body structure, growth, movement, and possible behavior. Some of the most important Allosaurus fossils were found in areas that preserve many Jurassic dinosaur remains. The fossil record shows that Allosaurus lived alongside several large plant-eating dinosaurs. Among these were sauropods, which were long-necked dinosaurs with large bodies, and armored dinosaurs that had protective structures on their bodies. These animals formed part of the environment where Allosaurus hunted. The presence of these large herbivores suggests that Allosaurus had access to a wide range of possible prey. Scientists have studied Allosaurus fossils to understand how it hunted large dinosaurs. Evidence from fossil sites suggests that it may have attacked animals much larger than itself. Hunting such prey required strength, coordination, and the ability to deal with powerful, defensive movements from the animals being attacked. Allosaurus had physical features that supported this lifestyle, including strong jaws, sharp teeth, gripping claws, and powerful legs. Some fossil discoveries contain signs of injuries on Allosaurus bones. These injuries show that individuals sometimes experienced difficult encounters with other animals. Broken bones and healed wounds provide information about the challenges these dinosaurs faced during their lives. Surviving injuries indicates that some individuals were able to continue living after suffering serious damage. Carnivorous was a unique meat-eating dinosaur that lived during the late Cretaceous period, about 72 million to 69 million years ago. It lived in the region that is now known as South America, where it moved through ancient landscapes filled with rivers, forests, open plains, and many other forms of life. The dinosaur belonged to a group of large predatory dinosaurs called theropods, which were mainly known for walking on 2 legs and having sharp teeth used for eating meat. The name Carnivorous means meat-eating bull. This name was given because of its unusual head shape and the two strong horns that grew above its eyes. These horns were among the most noticeable features of this dinosaur and made it different from many other large predators. The horns were not extremely long, but they were thick and strong, rising from the top of the skull above the eye area. Scientists believe these horns may have been used during interactions with other members of its species, possibly during displays, pushing contests or fights. They may also have played a role in helping individuals recognize each other. Carnotaurus had a body that was specially shaped for fast movement. It was not built with a heavy and massive frame like some other large predatory dinosaurs. Instead, its skeleton was relatively light, allowing it to move quickly. Its body had strong muscles, especially around the legs and tail, which helped it run across the ancient environments where it lived. The structure of its bones shows that speed and quick movements were important parts of its hunting ability. The dinosaur reached a length of about 8 meters and had a strong, muscular body. Its weight has been estimated by scientists to have been several tons, although exact estimates vary because only partial information is available from fossils. The known fossil remains show that Carnotaurus had a narrow body, long legs, and a long tail that helped it maintain balance while moving. Its overall body design suggests that it was capable of sudden bursts of speed when chasing prey or moving quickly through its environment. One of the most interesting features of Carnotaurus was its skull. Unlike many large predatory dinosaurs that had large and heavy heads, Carnotaurus had a relatively short and lightweight skull. The skull was built in a way that reduced its weight while still allowing it to have strong muscles connected to the jaw. This lighter skull helped reduce the amount of energy needed to move its head quickly. The short snout of Carnotaurus gave its head a different appearance from many other theropods. Its jaws contained many sharp teeth that were designed for cutting into the flesh of animals. The teeth were not extremely large, but they were effective for gripping and tearing food. The shape of the teeth suggests that Carnotaurus likely hunted animals that lived in the same environment, including plant-eating dinosaurs that shared its habitat. The jaws of Carnotaurus were strong but were likely not designed for crushing thick bones. Instead, its feeding style appears to have focused on quick bites and repeated attacks. Its skull structure suggests that it could open its mouth widely and use rapid movements of the head and jaws. This would have allowed it to attack prey efficiently. Carnotaurus had one of the most unusual sets of arms among large predatory dinosaurs. Its arms were extremely small and were positioned close to the body. They were shorter than those of many other theropods, and they had very limited movement. Each arm ended with 4 small fingers, but these fingers were not large enough to play a major role in hunting. The reason Carnotaurus had such tiny arms is still a subject of scientific study. The arms may have become smaller over many generations because they were not essential for survival. The dinosaur depended mainly on its jaws, legs, and body strength when hunting and moving through its environment. The reduced size of the arms did not prevent it from being an effective predator, because other parts of its body were highly developed. The legs of Carnotaurus were among its most important features. They were long, strong, and built for rapid movement. The bones of the legs show adaptations that helped the dinosaur move efficiently. Its thigh bones, lower leg bones, and feet were arranged in a way that supported speed and agility. Carnotaurus had a powerful tail that made up a large part of its body length. The tail helped balance the dinosaur while it ran. Since the body was positioned forward with a large head and strong legs, the tail worked as a balancing structure. This allowed the animal to make quick movements without losing stability. The muscles connected to the tail were also important for movement. A strong tail allowed the dinosaur to control its body while turning, accelerating, or stopping. This would have been useful when chasing prey across uneven ground or changing direction quickly. Scientists have learned about Carnotaurus mainly through the discovery of fossil remains found in Argentina. The most complete fossil specimen was discovered in the 1980s by the Argentine paleontologist José Bonaparte. The fossil was found in Patagonia, a region in southern South America that has produced many important dinosaur discoveries. The discovery of Carnotaurus provided scientists with valuable information about an unusual group of theropods known as abelisaurids. Abelisaurids were a family of predatory dinosaurs that lived mainly in the southern continents during the Cretaceous period. They had many unique features, including short skulls, strong bodies, and reduced arms. The fossil remains of Carnotaurus included a nearly complete skeleton, which allowed researchers to study many parts of its anatomy. The discovery helped scientists understand how this dinosaur moved, hunted, and interacted with its environment. Because the skeleton was so well preserved, researchers were able to examine details of its bones, muscles, and body structure. The skin impressions found with the Carnotaurus fossil were also extremely important. They provided evidence about the outer appearance of the dinosaur. The preserved skin showed that Carnotaurus had small scales covering much of its body. These impressions helped scientists understand that the dinosaur did not have feathers like some other theropods. The skin patterns revealed details about the texture and arrangement of its body covering. The environment where Carnotaurus lived was very different from the modern world. During the late Cretaceous period, South America had a warm climate with many different types of plants and animals. Rivers flowed through the landscape and forests provided habitats for many species. Carnotaurus lived among various dinosaurs, reptiles, and other prehistoric creatures. As a predator, Carnotaurus occupied a position where it hunted other animals for food. Its sharp teeth, powerful legs, and strong body allowed it to capture and consume prey. The exact animals it hunted are not completely known, but it likely fed on smaller dinosaurs and possibly young or injured individuals of larger species. The hunting style of Carnotaurus was likely based on speed and sudden attacks. Its lightweight body and strong legs suggest that it could move quickly over short distances. It may have approached prey carefully before using a rapid burst of movement to get close enough to attack with its jaws. Carnotaurus likely depended on its ability to move quickly and react rapidly when hunting. The structure of its body shows that it was not designed for slow movement or prolonged struggles with prey. Its long legs, strong muscles, and light skull were features that allowed it to make fast movements. When it attacked, it may have used its speed to close the distance between itself and its target before using its jaws to deliver bites. The way Carnotaurus captured prey has been studied through examinations of its skull and muscles. Scientists have found that its skull had areas that allowed some flexibility between the bones. This flexibility may have helped absorb stress when the dinosaur attacked. The skull was not completely rigid, and this structure may have allowed it to use quick biting motions. The bite of Carnotaurus was likely different from that of some other large theropods. Its jaws were not built mainly for crushing or breaking bones. Instead, they were shaped for grabbing and cutting flesh. The teeth were narrow, sharp, and curved slightly backward, which helped hold on to struggling animals. Once it caught prey, its neck muscles may have helped it pull back and remove pieces of flesh. The neck of Carnotaurus was thick and muscular. Strong neck muscles were important because the head needed support during movement and feeding. A powerful neck would have helped the dinosaur control its head during attacks and maintain balance while running. The connection between the head, neck, and body was an important part of its movement system. Carnotaurus had a relatively short face compared with many other large predatory dinosaurs. The shortened snout gave the skull a compact shape. This may have helped the dinosaur produce quick movements with its head. A shorter skull also reduced the weight at the front of the body, making movement easier. The horns above the eyes were a defining feature of Carnotaurus. These horns were made of bone and grew directly from the skull. They were positioned above the eyes and pointed slightly upward. Scientists have examined their shape and structure to understand their possible uses. The horns may have been involved in interactions between members of the same species. Many animals use head structures for communication, showing strength, attracting mates, or competing with others. Carnotaurus may have used its horns during physical contact with other individuals. The horns were not shaped like weapons designed for stabbing, but they could have been useful in pushing or striking. The eyes of Carnotaurus were positioned on the sides of its head, giving it a wide field of vision. Good eyesight would have helped it detect movement in its environment. As a predator, being able to notice potential prey and other animals would have been important. The position of its eyes also allowed it to observe its surroundings while moving. The brain structure of Carnotaurus has been studied through scans of its skull. These studies provide information about the areas of the brain connected to senses and movement. The dinosaur had a brain that supported strong coordination between its eyes, body, and muscles. This coordination would have helped it perform fast actions. Carnotaurus belonged to the abelosaurid family, a group of dinosaurs that became widespread in areas that were once part of the southern continents. These dinosaurs lived in regions that included South America, Africa, India, and Madagascar. Abelosaurids developed their own unique body features over millions of years. The ancestors of Carnotaurus were smaller animals that gradually changed through evolution. Over long periods of time, different populations developed traits that helped them survive in their environments. Carnotaurus represented one stage in the development of abelosaurid dinosaurs during the late Cretaceous period. The discovery of Carnotaurus helped scientists understand the diversity of predatory dinosaurs in South America. For many years, much of what was known about large theropods came from fossils found in North America and Asia. Carnotaurus showed that South America had its own distinct groups of large predators with unusual body structures. The fossil record from South America has revealed many important dinosaurs that lived during the Cretaceous period. The continent was separated from other land areas, allowing unique animals to develop. Carnotaurus was part of this separate evolutionary history. The muscles of Carnotaurus have been reconstructed by scientists using information from its bones. The attachment points on the skeleton provide clues about where muscles were located and how large they may have been. These studies suggest that Carnotaurus had strong muscles around its hips, legs, and tail. The hips were especially important because they supported the powerful hind limbs. Strong hip muscles helped generate force during walking and running. The legs carried the weight of the body and allowed the dinosaur to move across different types of terrain. The feet of Carnotaurus were also adapted for movement. The toes supported the body while walking and running. The claws on its feet may have helped provide grip on the ground. They could also have been useful during interactions with prey or other animals. Although Carnotaurus was a predator, it lived in an ecosystem where many other creatures existed. It shared its environment with plant-eating dinosaurs that formed an important part of the food chain. There were also smaller reptiles, insects, and other animals living in the same regions. The climate during the time of Carnotaurus was generally warmer than today. There were no modern continents in their current positions, and the landscapes of the world were different. South America had areas with forests and open spaces that supported many forms of life. The plants that grew during this period provided food for herbivorous dinosaurs. These plant-eating animals influenced the entire ecosystem because predators depended on them for survival. Carnivorous lived in an environment where changes in plant life and animal populations affected its ability to find food. The growth of Carnivorous throughout its life has also been studied. Like other dinosaurs, it likely went through different stages, from young individuals to adults. Younger Carnivorous would have had different body proportions and may have used different hunting methods before reaching full size. The bones of dinosaurs contain growth patterns that allow scientists to estimate their age and development. These patterns show how quickly the animal grew and how its body changed over time. Carnivorous appears to have grown rapidly during its early years before reaching adult size. The extinction of Carnivorous occurred at the end of the Cretaceous period, although it disappeared before the final mass extinction event that eliminated many dinosaur groups. The exact reasons why Carnivorous and many other dinosaurs disappeared from certain regions are still studied by scientists. Therizinosaurus was one of the most unusual dinosaurs ever discovered. It lived about 70 million years ago during the late Cretaceous period, a time when many different types of dinosaurs existed across the world. Its fossils were found in Asia, particularly in areas that are now part of Mongolia. When scientists first discovered its remains, they were surprised because the animal had a body structure that did not closely match many other known dinosaurs. The most remarkable feature of Therizinosaurus was its enormous claws, which were among the longest claws ever discovered from any animal. These large claws made the dinosaur appear extremely dangerous and created many questions about how it lived and behaved. The name Therizinosaurus means scythe lizard, a name given because of its huge, curved claws. The first fossils of this dinosaur were discovered in the middle of the 20th century in Mongolia. At first, scientists did not know exactly what kind of animal had produced the massive claws because only a few parts of the skeleton were available. The claws were so different from those of most known dinosaurs that early researchers had difficulty understanding the creature behind them. As more fossils were discovered and studied, scientists gradually learned that the claws belonged to a large dinosaur with a very unusual body. Therizinosaurus belonged to a group of dinosaurs called therizinosaurs. These dinosaurs were part of the larger group of theropods, which included many meat-eating dinosaurs. However, not all theropods were hunters. Over millions of years, some members of this group developed different diets and body features. Therizinosaurus was one of these unusual theropods. Although it was related to some predatory dinosaurs, evidence suggests that it mainly ate plants rather than hunting large animals. The body of Therizinosaurus was very different from the bodies of many other dinosaurs. It had a large body, a long neck, a small head compared with its body size, and powerful arms. Its arms were long and ended with 3 enormous claws. These claws were the most famous feature of the animal. Each claw could reach lengths of more than 70 centimeters, making them some of the largest claws known from any land animal. The claws were long, narrow and curved, giving the dinosaur a very unusual appearance. The exact purpose of these claws is still studied by scientists. Because the claws were extremely large, they likely had several possible uses. One possibility is that Therizinosaurus used them to pull branches towards its mouth while feeding. A large plant-eating dinosaur living in areas with tall vegetation would have needed ways to reach food that was difficult to access. The long claws may have helped it gather leaves, branches, and other plant material. The claws may also have been used for defense. Even though Therizinosaurus probably did not hunt other animals, it still needed protection from predators. During the late Cretaceous period, large meat-eating dinosaurs lived in parts of Asia. A dinosaur with such enormous claws would have had a useful method of protecting itself, if threatened. The claws may have allowed it to strike at attackers or create enough space to escape from danger. Another possible use of the claws was for display. Many animals today use unusual body features to communicate with others of their species. Large horns, feathers, colors, and other physical traits can help animals attract mates or establish dominance. Scientists have suggested that the large claws of Therizinosaurus may have played a role in communication or social behavior. However, because complete evidence is limited, the exact function of the claws remains uncertain. Therizinosaurus was a very large dinosaur. Scientists estimate that it may have reached lengths of around 9 to 10 meters. It had a heavy body supported by strong legs, and it probably walked on 2 feet. Its size and shape made it different from many other theropods. Instead of having a large head with sharp teeth designed for catching prey, it had a small head and a mouth adapted for eating plant material. The skull of Therizinosaurus has not been completely discovered, but related therizinosaur fossils provide information about what its head may have looked like. These dinosaurs generally had small skulls, long necks, and leaf-shaped teeth. Their teeth were useful for cutting and processing plants. The structure of their jaws suggests that they were adapted for a diet that included leaves and other vegetation. The diet of Therizinosaurus has been an important subject of research. At first, because of its relationship with predatory theropods and its enormous claws, some scientists thought it might have been a dangerous meat-eater. Later discoveries showed that Therizinosaurs had features associated with plant-eating animals. Their teeth, digestive systems, and body structure suggest that they consumed vegetation. A plant-based diet required a different lifestyle from that of hunting dinosaurs. Therizinosaurus likely spent much of its time searching for plants, leaves, and other available food sources. Its long neck would have helped it reach vegetation at different heights. Its large body required a significant amount of food, meaning it probably needed to spend many hours feeding. The environment where Therizinosaurus lived was very different from modern Asia. During the late Cretaceous period, the region contained forests, rivers, wetlands, and areas with rich plant life. Many different animals lived in these environments, including other dinosaurs, small reptiles, and early birds. Therizinosaurus shared its habitat with various creatures that were adapted to the conditions of that time. The climate of the late Cretaceous period was generally warmer than today. Plants grew in many areas, providing food for large herbivorous dinosaurs. Forests contained trees, ferns, and other vegetation that supported many plant-eating animals. Therizinosaurus lived in this environment and developed features that helped it survive there. The discovery of Therizinosaurus changed scientists' understanding of dinosaur evolution. For many years, theropods were mainly known as meat-eating dinosaurs, with sharp teeth and powerful jaws. The discovery of plant-eating theropods showed that this group was much more diverse than previously believed. Therizinosaurus demonstrated that dinosaurs related to predators could evolve completely different lifestyles. The unusual body of Therizinosaurus also helped scientists understand how different evolutionary paths could produce strange and specialized animals. Its large claws, long arms, small head, and plant-eating habits showed that dinosaurs developed many different forms over millions of years. The dinosaur was not built like a typical predator, even though its ancestors were part of a group that included famous hunters. Therizinosaurus probably moved differently from many other large dinosaurs. Its heavy body, long arms, and large claws would have affected the way it walked and behaved. It likely moved slowly while searching for food, using its strong legs to support its weight. Its arms were important tools for gathering plants and possibly defending itself. The large claws required careful movement. Because they were so long, Therizinosaurus needed to control them while walking and feeding. The claws were not simply weapons, but were parts of a complex body system. The dinosaur had to use them in ways that matched its lifestyle and environment. The fossil remains of Therizinosaurus have helped scientists study how dinosaurs adapted to different diets and environments. Fossils provide information about the bones, muscles, and possible behaviors of extinct animals. Although many details about Therizinosaurus remain unknown, each discovery has added more information about this unusual dinosaur. The relationship between Therizinosaurus and other therizinosaurs has also been studied. Members of this group shared several features, including long necks, small heads, large arms, and specialized claws. Over time, these dinosaurs developed different sizes and body shapes. Therizinosaurus became one of the largest and most recognizable members of the group. The feathers of Therizinosaurus are another important area of scientific discussion. Many theropod dinosaurs are now known to have had feathers or feather-like structures. Fossils of related therizinosaurs show evidence of feathers, suggesting that Therizinosaurus may also have had some type of feather covering. These feathers would have been part of its body covering and may have helped with temperature control. A feathered Therizinosaurus would have looked very different from the traditional image many people have of large dinosaurs. Its combination of feathers, huge claws, long arms, and plant-eating behavior shows how varied dinosaur appearances could be. The discovery of dinosaurs like Therizinosaurus has expanded scientific knowledge about the diversity of prehistoric life. The extinction of Therizinosaurus occurred at the end of the Cretaceous period. Many dinosaur species disappeared during this time due to major environmental changes. The event that caused the extinction of non-avian dinosaurs happened about 66 million years ago. Therizinosaurus lived several million years before this event and was part of the final stages of dinosaur history. Megaraptor was a remarkable predatory dinosaur that lived about 90 million years ago during the late Cretaceous period. It was discovered from fossils found in South America, a region that contained many different types of dinosaurs and other prehistoric animals during that time. Megaraptor belonged to a group of meat-eating dinosaurs known as Megaraptorans, a group recognized for their unusual body features, especially their very large claws on their hands. The name Megaraptor means large thief, referring to the enormous claws that were one of the most noticeable parts of its body. The discovery of Megaraptor changed the understanding of some predatory dinosaurs, because its body showed features that were different from many other large meat-eating dinosaurs. When scientists first studied its remains, they noticed a huge claw that appeared to come from the foot. Because many famous predatory dinosaurs had large curved claws on their feet, scientists originally believed Megaraptor was related to those animals. Later discoveries revealed that the large claw actually belonged to its hand. This showed that Megaraptor used its arms and hands in important ways when hunting. Megaraptor lived in South America during a period when the continents were arranged differently from today. The environment where it lived contained forests, rivers, open areas, and many kinds of animals. South America during the late Cretaceous period was home to several types of dinosaurs, including large plant-eating dinosaurs and powerful predators. Megaraptor lived in this environment as an active hunter that depended on its speed, agility, sharp senses, and powerful claws. The exact size of Megaraptor has been studied through fossil evidence, and scientists estimate that it reached a length of around 8 meters. Its body was built with features that suggest it was designed for quick movement. It had a long, narrow body, strong legs, a long tail, and relatively lightweight bones. These features helped it move efficiently through its environment while searching for food. One of the most important features of Megaraptor was its enormous hand claw. The claw was long, curved, and sharp. It was attached to a strong finger on each hand. The structure of this claw suggests that it was not simply used for decoration or display. Scientists believe it played an important role during hunting. The claw may have been used to grab, hold, and injure prey before the dinosaur used its teeth to feed. The arms of Megaraptor were unusually long for a large predatory dinosaur. They were well developed and contained strong muscles that allowed the animal to move its hands with force. The hands had several fingers, and the large claw was positioned in a way that allowed it to make contact with other animals. This arrangement gave Megaraptor the ability to interact with prey using its upper limbs. The hunting method of Megaraptor was likely based on catching and controlling animals. When approaching prey, it could have used its speed to move close and then used its large claws to grab the animal. The strong arms could have helped keep prey from escaping. Its sharp teeth would then have been used to tear flesh and consume the animal. The skull of Megaraptor was shaped for eating meat. It contained many sharp teeth designed for cutting and holding. The teeth were narrow and pointed, allowing the dinosaur to bite into the bodies of other animals. Unlike plant-eating dinosaurs that had teeth designed for grinding vegetation, Megaraptor had teeth suited for a diet based mainly on other animals. The head of Megaraptor was relatively lightweight, which helped reduce the overall weight of the body. A lighter skull allowed the dinosaur to move its head quickly while hunting. Fast movements of the head and neck would have helped it deliver bites during attacks. The eyes of Megaraptor were positioned to provide useful vision while moving through its environment. Good vision was important for a predator because it needed to locate animals, judge distances, and react quickly to movement. Its senses likely played an important role when searching for prey. The long tail of Megaraptor helped maintain balance while it moved. Predatory dinosaurs that ran after prey needed strong control of their bodies, especially when changing direction quickly. The tail helped stabilize the animal as it walked, ran, turned, and attacked. The legs of Megaraptor were strong and supported its body weight. Its body shape suggests that it was capable of active movement. It likely traveled across different environments in search of food and may have followed groups of animals that provided possible sources of nutrition. The fossils of Megaraptor have provided scientists with information about the evolution of predatory dinosaurs in South America. The animal belonged to a group that developed unusual features, including large hand claws and long arms. These characteristics show that different dinosaur groups developed different methods for hunting and surviving. Megaraptor was not a dinosaur with a heavy body structure. Its bones were relatively light, which reduced the amount of energy needed for movement. A lighter body allowed it to move more efficiently and maintain activity while searching for prey. Its physical structure combined strength with mobility. The discovery of Megaraptor fossils has mainly come from Argentina, where important dinosaur remains have been found. Fossils from this region have helped scientists understand the animals that lived in South America during the Cretaceous period. The rocks containing Megaraptor remains have also provided information about the environment and climate of that ancient world. The first known remains of Megaraptor were discovered in the 1990s. At first, the animal was classified differently because scientists only had limited fossil evidence. The discovery of additional remains later revealed the true structure of its body, especially the position of its large claws. This new information changed how researchers understood the animal. The hands of Megaraptor were among the most unusual features found in a large predatory dinosaur. Many large meat-eating dinosaurs depended heavily on their jaws and teeth, but Megaraptor had powerful front limbs that were important parts of its hunting ability. The development of these large claws shows that its ancestors followed a different evolutionary path. The claws were made of keratin during life, the same material found in modern animal claws. The fossil remains preserve the bones that supported these claws, allowing scientists to estimate their size and shape. The actual outer covering of the claw would have extended beyond the bone and created a sharp structure used during attacks. Megaraptor probably hunted smaller dinosaurs and other animals that lived in its environment. The exact prey it consumed is not always known, because fossil evidence rarely preserves direct evidence of feeding behavior. However, its teeth, claws, and body structure provide clues about its role as a meat-eating predator. The environment of South America 90 million years ago contained many opportunities for predators. Rivers and forests supported different types of animals. Plant-eating dinosaurs provided food sources for meat-eating species. Megaraptor lived as part of this complex ecosystem where many animals interacted with each other. Its body was adapted for movement and hunting rather than slow activity. The combination of long arms, strong legs, sharp teeth and large claws gave it several useful tools for finding and capturing food. These features developed over millions of years through changes in its ancestors. Mapusaurus was a large meat-eating dinosaur that lived during the late Cretaceous period, around 97 million to 93 million years ago. Its fossils were discovered in South America, in an area that is now part of Argentina. It belonged to a group of large predatory dinosaurs known as Carcharodontosaurids, a family that included some of the biggest meat-eating dinosaurs ever known. Mapusaurus was closely related to Giganotosaurus, another enormous predator from South America, and both animals shared many features that helped them hunt and survive in their environment. The name Mapusaurus means earth lizard or land lizard. The name comes from the Mapuche people, an indigenous group from the region where the fossils were found, and the Greek word sauros, meaning lizard. The dinosaur was officially described in the early 21st century after scientists studied a large collection of fossil remains discovered in Argentina. The discovery provided important information about the lives of large predatory dinosaurs in South America during the Cretaceous period. Mapusaurus was a large animal with a long body, strong legs, a powerful tail, and a large head filled with sharp teeth. Scientists estimate that it may have reached lengths of more than 10 meters. Its exact size is difficult to determine because the known fossils represent several individuals of different ages, including young and adult animals. Some fully grown individuals may have been among the largest predators in their environment. The body of Mapusaurus was built for active hunting. Its strong hind legs supported its weight and allowed it to move across the landscape while searching for prey. Like other large theropod dinosaurs, it walked on two legs, with its long tail helping it maintain balance while moving. The tail was made of many connected bones and strong muscles that helped control body movement during walking, running, and sudden changes in direction. Its skull was large and strongly built. The skull contained many sharp, blade-like teeth that were designed for cutting flesh. The teeth were not shaped for crushing bones, but for slicing through the bodies of other animals. Each tooth had edges that were able to cut into meat, allowing Mapusaurus to remove pieces of flesh from prey. The jaws were powerful and could deliver strong bites, although the exact strength of its bite is still studied by scientists. The head of Mapusaurus was long and narrow, a feature common among carcharodontosaurid dinosaurs. This skull shape helped create space for many teeth and supported a hunting style focused on using the jaws to injure and weaken prey. The animal likely depended on repeated bites that caused serious wounds rather than relying on a single crushing bite. Mapusaurus lived in a world very different from the modern Earth. During the time it existed, the continents were arranged differently, and South America was separated from many other land areas. The climate in the regions where Mapusaurus lived was warmer than today, with large areas of forests, rivers, and open spaces. These environments supported many different kinds of animals, including plant-eating dinosaurs that served as food sources for large predators. One of the most important discoveries about Mapusaurus came from a fossil site that contained the remains of several individuals. Many bones belonging to different Mapusaurus dinosaurs were found together, including animals of different sizes and ages. This discovery led scientists to study the possibility that these dinosaurs may have lived or hunted in groups. The idea that Mapusaurus may have hunted in groups is based on the fossil evidence found at the site. When many individuals of the same predator are found together in one location, it can suggest that they may have gathered around the same place during life or after death. Scientists consider several possible explanations, but the discovery provides evidence that Mapusaurus may have had some form of social behavior. If Mapusaurus hunted in groups, multiple individuals could have worked together when attacking large animals. This would have been useful because some of the plant-eating dinosaurs living in the same region were extremely large. One possible prey animal was a sauropod dinosaur called Argentinosaurus, which was one of the largest land animals known to science. Sauropods had enormous bodies, long necks, and powerful legs, making them difficult prey for a single predator. A group of Mapusaurus individuals may have been able to surround, follow, and attack very large prey. Younger or weaker animals within a herd of plant-eating dinosaurs may have been easier targets. Scientists study the teeth marks, fossil locations, and body structures of dinosaurs to understand how these predators may have interacted with their prey. However, the exact hunting methods of Mapusaurus remain uncertain. Fossils can provide clues about behavior, but they do not record every action an animal performed while alive. Scientists continue to examine evidence from Mapusaurus and other related dinosaurs to understand their lifestyles, movements, and feeding habits. Mapusaurus shared its environment with many other prehistoric animals. South America during the late Cretaceous period contained a wide variety of dinosaurs, including large plant-eaters, smaller predators, reptiles, and other creatures. The presence of large herbivorous dinosaurs provided enough food to support enormous carnivores like Mapusaurus. The discovery of Mapusaurus helped scientists learn more about the evolution of giant predatory dinosaurs in South America. Before its discovery, many details about these animals were unknown. Fossils from Mapusaurus showed that large carcharodontosaurid dinosaurs were diverse and successful in South America during the Cretaceous period. The relationship between Mapusaurus and Giganotosaurus is important in understanding dinosaur evolution. Both belonged to the same family and had similar body structures, including large skulls, strong jaws, and long tails. Their fossils show that South America produced some of the largest meat-eating dinosaurs known from the fossil record. The growth of Mapusaurus is also an area of scientific interest. Because fossils from different sized individuals have been discovered, researchers can study how the dinosaur changed as it grew. Young Mapusaurus individuals would have had different body proportions compared with adults. Their skulls, limbs, and overall body shape changed as they matured. Young predators often had different hunting abilities from adults. A smaller Mapusaurus may have hunted smaller animals or depended on adults if they lived in groups. As individuals grew larger and stronger, they would have become capable of attacking bigger prey. The discovery of multiple Mapusaurus fossils at one location also gives scientists information about dinosaur communities. It shows that large predators could exist in areas where there were enough resources to support them. The presence of both young and adult individuals suggests that these animals may have remained in the same general area during parts of their lives. Mapusaurus had features that helped it survive as a large predator. Its sharp teeth allowed it to eat meat efficiently. Its strong legs allowed it to travel across large areas in search of food. Its powerful tail helped with movement and balance. Its large size gave it the ability to attack and consume large animals that smaller predators could not easily handle. The environment where Mapusaurus lived likely changed over millions of years. Rivers shifted, plants changed, and animal populations appeared and disappeared. Dinosaurs had to adapt to these changing conditions. Mapusaurus survived during a period when large predatory dinosaurs were common in many parts of the world. Majungasaurus was a large meat-eating dinosaur that lived on the island of Madagascar during the late Cretaceous period, around 70 million to 66 million years ago. It belonged to a group of predatory dinosaurs called abelisaurids, which were known for their strong skulls, powerful bodies, and unusual head shapes. The fossils of Majungasaurus have provided scientists with important information about the animals that lived in Madagascar, at a time when the island had a unique collection of prehistoric creatures that were different from many animals found in other parts of the world. The name Majungasaurus means Mahajanga lizard. It was named after the Mahajanga region in northwestern Madagascar, where many of its fossils were discovered. The discovery of this dinosaur helped scientists understand more about the evolution of predatory dinosaurs in isolated environments. Madagascar was separated from many other land areas during the time Majungasaurus lived, and this allowed many unusual animals to develop there over millions of years. Majungasaurus was a medium-sized to large predator. Scientists estimate that it reached a length of around 6 to 7 meters, although the exact size may have varied between individuals. Its body was strong and heavily built, with powerful muscles supporting its movement. It had a large head with a thick skull structure, and this skull was one of the most noticeable features of the animal. The strong bones of its head gave it a powerful appearance and helped support the forces created when it used its jaws. The skull of Majungasaurus was short, deep, and strongly built. Unlike some other predatory dinosaurs that had long and narrow skulls, Majungasaurus had a compact skull designed to handle strong biting forces. The bones of its head were thick and parts of the skull were connected in ways that increased strength and stability. These features allowed the dinosaur to use its jaws effectively when feeding. The jaws of Majungasaurus contained many sharp teeth that were curved and suited for cutting flesh. Its teeth were not extremely long, but they were strong enough to hold and tear pieces of meat from animals it hunted or scavenged. Like many predatory dinosaurs, its teeth were replaced throughout its life because they became worn or damaged during feeding. New teeth developed inside the jaw and moved into position when older teeth were lost. Majungasaurus had a number of small raised areas on its head, including a small horn-like structure above its eyes. This feature gave the dinosaur a distinct appearance. The horn was not large, but it was formed from thickened bone and may have been used in displays between members of the same species. Many dinosaurs had structures on their bodies that may have helped them recognize each other, communicate, or establish dominance. The arms of Majungasaurus were very small compared with the rest of its body. They had short bones and limited movement. The hands had fingers with small claws, but the arms were not the main tools used for capturing prey. Most of the work involved in hunting and feeding was likely carried out by its head, jaws, and strong neck muscles. Its body shape shows that it depended heavily on its powerful skull and mouth. The legs of Majungasaurus were strong and supported its weight. Its hind limbs were muscular, allowing it to walk and move saison across the landscapes of ancient Madagascar. Although it was not built for extremely fast running, it was capable of moving effectively through its environment while searching for food. Its tail helped provide balance while it walked and turned. During the time Majungasaurus lived, Madagascar was home to a variety of prehistoric animals. The island had rivers, forests, and open areas where different species lived. The climate was warmer than today, and the environment supported many plants and animals. Majungasaurus shared this habitat with other dinosaurs, ancient crocodile relatives, turtles, fish, and small mammals. The fossils of Majungasaurus were mainly discovered in the Maevarano Formation, a geological area in Madagascar that preserves many remains from the late Cretaceous period. The rocks of this formation have helped scientists study the ancient environment of Madagascar. Fossils found there include bones, teeth, and other remains that provide evidence about the animals that lived in the region. The discovery of Majungasaurus began with fossil findings in the early 20th century, but later research revealed much more about the dinosaur. Scientists studied additional remains found during expeditions to Madagascar and were able to identify many details about its anatomy, behavior, and lifestyle. The large number of fossils available has made Majungasaurus one of the better-known abelisaurid dinosaurs. One of the most unusual discoveries connected to Majungasaurus was evidence suggesting that it may have eaten members of its own species. Scientists found bones from Majungasaurus that had marks and damage patterns similar to those caused by feeding activity. Some of these bones showed signs that another Majungasaurus may have bitten or consumed them. The possibility of cannibalism in Majungasaurus has attracted significant scientific interest. Cannibalism occurs when an animal eats another individual of the same species. In the case of Majungasaurus, researchers believe this behavior may have happened during times when food sources were difficult to find. Environmental conditions in ancient Madagascar may have created periods when predators struggled to obtain enough food. The evidence does not mean that Majungasaurus only ate members of its own species. Its main diet likely consisted of other animals that lived in its environment. It probably hunted smaller dinosaurs and other available prey. It may also have eaten animals that had already died. The discovery of possible cannibalism provides information about how some predators responded to difficult conditions. The feeding behavior of Majungasaurus was connected to its powerful skull and jaws. A strong head allowed it to process different types of food sources. Its thick skull bones could handle stress from biting, pulling, and tearing. The structure of its neck muscles also suggests that it could deliver strong movements with its head while feeding. Majungasaurus was a member of the abelisauriid family, a group of theropod dinosaurs that lived mainly in the southern continents during the Cretaceous period. Abelisaurids had several common features, including short skulls, strong necks, reduced arms, and powerful hind limbs. However, each species developed its own unique features depending on the environment where it lived. The isolation of Madagascar influenced the development of Majungasaurus. Because the island was separated from many other landmasses, the animals living there followed their own evolutionary paths. Over millions of years, species adapted to the conditions of the island. Majungasaurus became one of the dominant predators in this environment. The world during the late Cretaceous period was very different from the modern world. Continents were positioned differently. Sea levels were often higher, and many groups of animals that no longer exist were widespread. Madagascar was already separated from Africa and other land areas, creating a distinct ecosystem where unique animals evolved. Majungasaurus lived before the mass extinction event that occurred around 66 million years ago. This event caused the disappearance of many dinosaur species and changed life on Earth. The fossils of Majungasaurus provide information about the final part of the age of dinosaurs and show the types of predators that existed shortly before this major change in Earth's history. Acrocanthosaurus was a large meat-eating dinosaur that lived during the early Cretaceous period, about 115 million years ago. Its fossils have been discovered in North America, showing that this animal lived in areas that were part of the ancient landscapes of the continent during a time when dinosaurs were the dominant large animals on land. The environment where Acrocanthosaurus lived included forests, rivers, floodplains, and areas with many different types of plants and animals. These environments provided food sources for many dinosaur species, including large plant-eating dinosaurs that became prey for powerful predators. The name Acrocanthosaurus means high-spined lizard, referring to the 4-ton-tall projections that extended upward from the bones of its backbone. These structures were one of the most noticeable features of this dinosaur. The spines were formed from the extensions of the vertebrae, which are the bones that make up the spine. Scientists have studied these unusual structures to understand their possible functions. The exact purpose of the tall spines is still discussed by researchers, but they were likely connected to the muscles and tissues along the back and may have helped support the powerful body of the animal. Acrocanthosaurus had a very large and heavy body. It was among the biggest predators known from North America during the time in which it lived. Scientists estimate that it could grow to lengths of around 12 meters. Its size gave it the ability to attack and feed on large animals that lived in the same environment. Its body was built with strong bones, large muscles, and a powerful structure that supported its movement across the land. The skull of Acrocanthosaurus was large and strongly built. It contained many sharp teeth designed for cutting through the flesh of other animals. The teeth were curved and had edges that helped the dinosaur hold onto prey and remove pieces of meat. Like many large predatory dinosaurs, Acrocanthosaurus depended heavily on its jaws when attacking animals. Its skull had strong areas for muscle attachment, allowing it to produce powerful bites. The jaws of Acrocanthosaurus were long and filled with teeth arranged along the upper and lower parts of the mouth. Each tooth was shaped to handle the struggles involved in hunting large prey. When it captured an animal, its teeth helped prevent the prey from escaping, while its jaws delivered powerful bites. Broken and replaced teeth were common among predatory dinosaurs because hunting could damage teeth and new teeth regularly grew to replace worn or lost ones. The arms of Acrocanthosaurus were strong and well developed. Although many large meat-eating dinosaurs had smaller arms, Acrocanthosaurus had arms that were capable of performing useful actions. Its arms ended in hands with 3 fingers, and each finger had a large curved claw. These claws may have helped it hold on to struggling prey. The muscles connected to the arms and shoulders were strong, giving the dinosaur additional strength when using its front limbs. The legs of Acrocanthosaurus were powerful and supported its enormous body weight. Its hind limbs contained large bones and strong muscles that allowed it to move across the ground. The feet had strong toes with claws that helped provide stability while walking and running. The structure of its legs shows that it was a predator, adapted for moving through its environment while searching for food. Acrocanthosaurus belonged to a group of theropod dinosaurs. Theropods were a major group of dinosaurs that included many meat-eating species. Members of this group had several features connected to hunting, including sharp teeth, strong jaws, grasping hands, and bodies designed for active movement. Acrocanthosaurus was part of the group called Carcharodontosaurids, a family of large predators known from different parts of the world. The discovery of Acrocanthosaurus fossils helped scientists learn more about large predators that lived during the early Cretaceous period. The first remains were discovered in North America during the 20th century. Fossil discoveries included parts of the skull, backbone, limbs, and other sections of the skeleton. By studying these remains, researchers were able to reconstruct the appearance and lifestyle of this dinosaur. The fossils show that Acrocanthosaurus had a body shape suited for hunting large animals. Its long body, strong neck, powerful jaws, and muscular limbs provided the physical features needed for a predator that attacked large prey. Its neck muscles were especially important because they helped support the large head and allowed it to move its jaws and head during feeding. The tall spines along its back made Acrocanthosaurus unusual among large predatory dinosaurs. These spines extended from many vertebrae and were especially noticeable in the shoulder and back regions. Scientists have examined these structures carefully because they provide information about the muscles and soft tissues that once covered the dinosaur's body. The spines may have supported strong muscles that helped control movements of the neck, back, and body. The body of Acrocanthosaurus was designed for strength. Its skeleton shows signs of a heavily built predator capable of dealing with large prey animals. Its bones were thick and strong, and many parts of its body had large areas where muscles attached. These features indicate that it relied on physical power when hunting and feeding. During the time Acrocanthosaurus lived, North America was home to many types of dinosaurs. Large plant-eating dinosaurs moved through the same regions, providing possible sources of food for predators. Animals such as sauropods and large ornithopods lived in these environments, and evidence suggests that Acrocanthosaurus may have hunted some of these large herbivorous dinosaurs. Hunting a large dinosaur required strength, careful movement, and powerful weapons. Acrocanthosaurus had several features that helped it capture prey, including strong jaws, sharp teeth, muscular arms, and heavy legs. Scientists believe that it may have attacked large animals by using its jaws and claws together. The exact methods it used during hunting cannot be observed directly, but its anatomy provides clues about how it may have behaved. The feeding habits of Acrocanthosaurus were connected to the animals that lived around it. Large predators often depended on available prey in their environment. When large herbivorous dinosaurs were present, they provided enough food to support powerful hunters. Acrocanthosaurus likely moved through its habitat, searching for suitable animals to attack or feed upon. The remains of Acrocanthosaurus provide information about injuries and physical struggles during its life. Some fossils show signs of damage that healed while the animal was alive. Such injuries may have resulted from fights with other animals, accidents, or difficulties during hunting. The ability of the bones to heal shows that the dinosaur survived serious challenges during its lifetime.